want to show you distribution on your micro exam you just took. Okay. Here's micro exam stats. High score is 95, low score is 57. Pretty tight distribution over here. Okay, really good distribution. We had 2 outliers, but otherwise good distribution. The average was 81. So I think you guys pretty much have the hang of things. No.
Getting
We're getting there. Okay, well the next exam is going to be like this, you know, pretty much the same. Going for highlights, vectors, you know, some overall mechanisms, you know, the names of diseases, and the names of the organisms that cause diseases. What makes the organism unique? That's what I'm usually going for. Okay, any questions about that exam? All right, so we're going to continue discussing neoplasia. Again, be careful with this topic. This topic can be confusing, especially in the tests. You have to apply some of this. So you just want to make sure you understand the material. Okay, so last time we introduced you to what a neoplasm is. Neoplasm is a group of autonomously proliferating cells. That is, the cells proliferate wherever and whenever they want. This is in contrast to other types of cells. When they proliferate under the influence of things like growth controls, growth hormones, crowded conditions. Okay? They will respond to various bodily controls of proliferation. When those cells proliferate, we call them hyperplastic cells. Hyperplastic cells obey growth controls. Neoplastic cells do not obey growth controls. They proliferate wherever and whenever they want. Now, we can subdivide neoplastic cells into 2 types. We've got the benign, we've got the malignant. Malignant neoplasms are also collectively referred to as cancers. Benign neoplasms are not called cancers. They are autonomously proliferating cells, but they are not cancers. Only the malignant neoplasms are called cancers. Now, in both cases, benign and malignant neoplasms tend to grow, forming some sort of irregularity in the tissue, a bump in the tissue. Another word for a bump, kind of bumpy irregularity, is a tumor. And so benign and malignant neoplasms may be collectively referred to as tumors because they make some sort of bump as they grow. Okay? Now we defined the characteristics of benign and malignant neoplasms. We said that benign neoplasms only grow locally, generally starting off as one cell that loses proliferative control. That one cell divides into 2, 4, 8, 16, 32, etc. As it grows, it can only grow locally, so it has to grow by pushing up against its surroundings. Well, that causes the surrounding tissue to atrophy. And as the tissue atrophies, it leaves this rim of atrophic tissue around the expanding neoplasm. That rim of atrophic tissue is called a pseudocapsule. The pseudocapsule represents a natural tissue barrier. Now, since benign neoplasms can only grow locally, they must grow within the confines of that natural tissue barrier, that pseudocapsule. They have no ability to punch through the pseudocapsule. They have no ability to extend beyond the pseudocapsule. They are contained within the pseudocapsule. And that gives the benign neoplasm certain macroscopic characteristics that we can recognize. The boundaries are very well delimited. You know exactly where that tumor ends and where normal tissue begins. The contour of the margins, the boundaries, very smooth. Okay? Generally smooth contour, not irregular, very smooth, well delimited. Okay? That's all the characteristic features of a benign neoplasm. Malignant neoplasms, in contrast, have additional characteristic features. They too will start off by growing locally. One One cell will divide into 2, 4, 8, etc. And they will begin by expanding against the surrounding tissue, again, causing the tissue to pressure atrophy. As the tissue atrophies again, this will leave a rim of atrophic tissue around the expanding malignant neoplasm. However, unlike the benign neoplasm that must grow within the confines of that pseudocapsule, the malignant neoplasm has the ability to penetrate natural tissue barriers, so it can punch through that pseudocapsule and extend beyond the confines of the pseudocapsule. When it does this, when it penetrates a natural tissue barrier, we call that local invasion. Local invasion. Local invasion is a defining feature of malignancy. Benign neoplasms do not locally invade. Now, as a result of the local invasion, the ability to penetrate natural barriers, some of the macroscopic features of malignant neoplasm tend to be different. If you look at the borders of malignant neoplasm, they tend to be blurry. That's because there's local invasion. There's some cells are breaking through the natural boundary, and that blurs the borders. Also, the boundaries tend to be irregular. You got some parts of the neoplasm sticking way out, others are kind of close to the original tumor mass. That makes the boundaries very irregular. All of that is due to local invasion. Local invasion is a defining feature of malignancy. Benign neoplasms do not locally invade. If you're ever given a question, you're told, hey, this neoplasm is locally invading, it isn't benign, it's malignant. Okay, other features that are characteristic of a malignancy. Metastatic dissemination. Malignant neoplasms have the ability to metastatically disseminate. The cells of the primary mass can detach, get into, lymphatics, vasculature, and spread all over the place. They tend to get caught in small blood vessels like the sinusoids of the liver or the pulmonary capillaries of the lung, and they lodge there. And when they lodge there, they start to grow, and they make these little colonies that we call metastatic foci. That dissemination of cells is referred to as metastatic dissemination or metastatic spread. Only malignant neoplasms have the ability to metastasize. Benign neoplasms can't metastasize. So if you ever get a question that describes metastatic dissemination, by definition, that is a malignancy. Any questions on that? That we talked about last week. All right. Well, I started showing you some examples of the macroscopic and microscopic features of benign versus malignant neoplasms. Then we got to a point where we started looking at the evolution of a neoplasm. Okay? We looked at this in the context of the lungs of a cigarette smoker. Okay? We looked at it in kind of a diagrammatic form first. We looked at a section through an airway. There's the lumen of the airway. There's the respiratory epithelium. There's the basement membrane the respiratory epithelium kind of sits on. That's a natural tissue area. Below that, you've got the subepithelial tissues. Now, normally, this respiratory epithelium consists of a pseudostratified ciliate epithelium. Cilia is covered with mucus. You inhale any adulterants or mites or anything like that, it's stuck in the mucus of the cilia, bring it up to the oropharynx, where it can be swallowed or expectorated. But they're very delicate kind of cells. Pseudostratified ciliate cells, very delicate. Someone smokes a cigarette. The toxins in the cigarette smoke, the heat in the cigarette smoke cause these cells to degenerate. And as a result, they have to be replaced. Well, the cells that replace them lie underneath the basement membrane. They're called stem cells. These stem cells enter into the mitotic cycle, give rise to daughter cells. The daughter cells will differentiate into these pseudostratified ciliates, columnar cells, repopulating that area of the respiratory lumen that's been denuded of epithelial cells. And these pseudostratified ciliated cells that are damaged are replaced. That can go on for a while. Keep cigarette smoking, these cells will degenerate. At some point, however, the stem cells down here are going to change their gene expression.
they're going to change their gene expression such that the cells that replace these degenerating delicate cells are going to be able to better handle the harsh conditions generated by cigarette smoke. Instead of the stem cells differentiating to these ciliated cells, which are very delicate, instead they will differentiate into a tougher cell, which is the squamous cell. And eventually what will happen is that the stem cells will change their gene expression such that instead of generating this delicate cell, they will generate a pseudostratified, a stratified squamous type cell. These epithelium consists of squames, all of which look normal. They have a very small nucleus, big cytoplasm, and are nicely layered and architecturally organized. Okay. What has happened is that this pseudostratified ciliated columnar epithelium has been replaced with a stratified squamous epithelium. Now, we know that this is called metaplasia, specifically squamous metaplasia. And again, that's an adaptation mechanism we studied before. It is an adaptation mechanism that allows the epithelium to tolerate the harsh conditions of the cigarette smoke. However, although this stratified epithelium, this stratified squamous epithelium, is tougher than the ciliated epithelium, it still is not impervious to cigarette smoke. It'll still be damaged by the cigarette smoke. And these cells will also begin to degenerate. When they degenerate, the stem cells have to replace them. Because of this, the stem cells are dividing and differentiating at an accelerated rate. And we said that when you have cells dividing at an accelerated rate, they have to replicate their DNA at an accelerated rate. When they do that, they make a lot of mistakes replicating the DNA. Some of those mistakes are corrected, some of those mistakes are not corrected. The mistakes that are not corrected persist as mutations. So as these cells constantly degenerate, regenerate, mutations develop in these cells. And the cells start to look abnormal. They start to look funny or atypical. They don't look like normal squames. And as they continue to mutate, not only do they look funny, but they start to lose proliferative control, and they start to crowd each other. When this happens, the epithelium goes from looking like this to looking something like this. Here's a section through the airway of a cigarette smoker, probably a few years after they've started smoking. There's the lumen, again there's the epithelium. Basement membrane, which is a natural tissue barrier, and you got the subepithelial tissues here. Look at these cells. These are the cells making up the epithelium. They're squamoid, but do they look like normal squames? No. They don't have the morphology of a normal squame. Some of them might, but most of these cells look kind of odd or atypical for squames. We would call them atypical squames. But there's some other issues here. The cells don't look anything like each other. This cell, for example, doesn't look anything like that cell. That cell doesn't look anything like that cell. There are a variety of different looking cells, very many different forms. We call that pleomorphism. Pleomorphism, many different forms. But you can see pleomorphism in these cells because all of the cells are acquiring different mutations over time. The DNA is getting so mutated, cells don't look anything like each other. But there's something else very disturbing about this. The cells look very crowded. They're very disorganized. The nucleus is big in proportion to the cytoplasm. That's unusual for squames as well. Well, the reason they're all kind of densely packed together like this is because they're losing proliferative control. Cells should not crowd themselves like this. They're crowding themselves because they're losing the ability to regulate their proliferation. They're becoming neoplastic. And you can see here, despite the fact they're all crowded and jammed together, you still have these. These are cells in the process of division. They're called mitotic figures. These mitotic figures are just cells that are in the process of dividing. When the cells are this crowded together, they should never be dividing. The cells have lost proliferative control. Definition of cells losing proliferative control or having no proliferative control is a neoplasm. This is an example of an epithelium that contains neoplastic cells. But you'll notice that these neoplastic cells remain confined above the basement membrane. That basement membrane is a natural tissue barrier. It's not penetrating a natural tissue barrier. These cells are not penetrating this basement membrane. And so the cells are not displaying any of the characteristics of malignancy. These cells, whatever they are still benign. They are neoplastic, but they're benign. Now, sometimes we call this condition intraepithelial neoplasm, because it's a neoplasm confined to the epithelium. More likely, though, we'll describe this overall epithelium, the crowded cells, the abnormal architecture, the overall disorganization and pleomorphism. We would describe this epithelium as being dysplastic. This is dysplasia. Now again, it's a benign condition. By definition, dysplasia is benign. Okay, we've got intraepithelial neoplasm. It's not invading. This is benign. Whatever it is, it's benign. That's dysplasia. The problem with dysplasia is it's the immediate antecedent to the development of cancer. Okay. A couple other things you notice about these cells. Yes, they're all crowded together. Clearly, that's a problem. Okay? Take a look at the cell morphology. You notice the nucleus here is big in proportion to the cytoplasm. Okay? That's abnormal for a squame. Usually, a squamous cell has a rather small nucleus and a big cytoplasm. Normally, we say that this cell has an NC ratio that is low. Okay? The nucleus is small in proportion to the cytoplasm. These cells are different. These cells have a rather large nucleus in proportion to its cytoplasm. We say that this cell has an NC ratio which is high. This high NC ratio correlates with immaturity. When you see a cell like this that has a high NC ratio, it's immature. Why are these cells immature? Look, they all have high NC ratios. Why are they all immature? Because they're constantly proliferating. They don't have time to mature. So all of these cells, not only crowded, not only atypical, but because they have high NC ratios, we describe them as being immature. This whole epithelium is immature. It consists of immature cells. All right, any questions on this? Nucleus to cytoplasmic ratio. NC ratio. Okay, a few things can happen here. Person can continue to smoke, and maybe these cells won't give that person any trouble at all. Maybe the person will stop smoking. If the person stops smoking, the best thing that can happen is the immune system will recognize that these cells are abnormal, destroy the cells, and the cells that are abnormal will eventually be replaced with normal pseudostratified ciliated cells again. Everything will be fine. There's another possibility. We said last time, sometimes if the person continues to smoke, these cells will continue to mutate. If they continue to mutate, they may accidentally turn on a gene that codes for some sort of protease that allows them to eat through that natural tissue barrier. If they do, this is what happens. They break through. And they start invading into the subepithelial tissues. This is called local invasion. Whatever this is, it is now malignant. It's malignant because now it's displaying a feature that's consistent with malignancy. Local invasion. Local invasion is a defining feature of malignancy. Okay? And this is clearly breaching a natural tissue barrier, which of course defines local invasion. Okay, any questions on that? We did that last week. All right. Now, we looked at the evolution of cancer in diagrammatic form. Now we want to take a look at some actual specimens to see how the cells evolve over time into some sort of locally invasive cancer. Now, the best way to do this is take a look at the cervix. Cervical epithelium very often becomes dysplastic and cancerous as a result of an oncogenic infection, viral infection by HPV. There are a number of different serotypes of HPV that are oncogenic. Which ones are oncogenic? Which serotypes? You should know 3 of them right off. HPV serotypes, which are oncogenic. Those are some common oncogenic serotypes. There are more. These are the most common. Very often, a woman will develop cervical cancer as a result of a human papillomavirus infection of the oncogenic serotype 16, 18, and or 31. These infections generally first cause the cervical epithelium to become dysplastic. If nothing's done about it, that cervical dysplasia could evolve into a locally invasive squamous cell carcinoma. Okay, let's take a look at the evolution of this cervical cancer. Let's first take a look at normal cervix. Here, this is a transverse section through the vaginal canal. You can see the vaginal canal here. Those are the rugal folds in the vaginal canal. And over here you can see the cervix, and in the background you can see the uterus, and the fundus is up here. Okay. This is a normal looking cervix. Okay, we're seeing the exterior of the cervix. The exterior of this cervix is invested by a stratified squamous epithelium. The exterior of the cervix is referred to as the ectocervix, and most of the ectocervix is invested by a stratified squamous epithelium. Over here we have an opening that leads up to the uterine cavity. It's called the cervical os. Inside we have the endocervical canal that leads right up to the endocervical cavity. Okay. Look at the gross appearance of the cervix. Again, notice it is smooth, shiny, and glistening. Okay, that's the appearance of a healthy cervix. That's the way a cervix should look when everything is healthy. Okay, let's take a look at the cervical epithelium. We're going to take a section through the cervical epithelium right here. Okay. Here's a section through the ectocervix. Okay, you can see out here we've got the vaginal canal, and over here we have the epithelium, and these are subepithelial tissues there. Let's take a look at this. The cervical epithelium is invested by a stratified squamous epithelium. You can clearly see that this is a stratified squamous epithelium. We generally subcategorize different zones of the cervical epithelium into 3 different sections. We've got the parabasal cell layer down here, we've got the intermediate cell layer here, and we've got the superficial cell layer here. Let's take a look at the parabasal cell layer. Parabasal cell layer is down here. You can see it consists of a lot of squamoid cells that are kind of crowded together. That's normal for the parabasal cell layer. The parabasal cell layer is constantly proliferating to give rise to squames that are sloughed off into the cervical canal periodically, or the vaginal canal. Constantly wants to regenerate the cervical epithelium. Well, these are the cells that do it, and so they're constantly proliferating to replace these squames that slough off. Notice that the cells have very high NC ratios. The nucleus is very big in proportion to the cytoplasm. Okay? That's because they're immature. And why shouldn't they be immature? They're constantly proliferating. They should be immature. But that's normal for the parabasal cell layer. But notice that as the cells move up the epithelium, they change their cytomorphology. The nucleus gets small in proportion to the cytoplasm. And so the NC ratios start to decrease. You can also see that the cells start assuming a very definitive architecture. They have a definitive orientation, longitudinal axes of all these cells start to line up, become parallel. There's definite organization here. There is a definite reduction in the NC ratio. That's because these cells are maturing. They're going from immature to more mature form. When the epithelium does that, when the cells of the epithelium does that, we say that the epithelium is maturing properly. That's what we should see in the cervical epithelium. As we go up to the superficial cell layer, you can see these cytomorphologic changes continue. When we get up here, we have an extremely small nucleus and a very large cytoplasm. So the NC ratios decrease even further. Again, because the cells are continuing to mature. As they migrate upward here towards the superficial layer, the cell cytomorphology is indicative of a very mature type of cell. And again, you'll notice that there is this architectural organization. When the cells do that across the entire thickness of the epithelium, we say the entire epithelium is maturing properly. This is what the epithelium of the cervix should be doing. Okay. Nothing wrong with this epithelium at all. Everything looks good. All right. Questions on that? Let's take a look at what happens to the cervical epithelium when it becomes dysplastic. Now, there are different degrees of dysplasia. There's mild, there's moderate, there's severe form of dysplasia. Let's take a look at an example of a moderate form of dysplasia. This is a type of dysplasia that can be caused by HPV, specifically the oncogenic serotypes. Take a look at this section through cervical epithelium. Again, we've got the vaginal canal out here. There's the cervical epithelium. We've got a basement membrane that runs underneath here. And then we got the subepithelial tissues over here. Okay? All right, let's start with the parabasal cell layer. Okay, parabasal cell layer consists of cells that are very mature looking, very high NC ratios, big nucleus, small cytoplasm, again, all very crowded together. Well, that's certainly not unusual for the parabasal cell layer. They're supposed to be immature. They're the cell layer that's supposed to be proliferating. Okay? Well, that's okay. But take a look at what happens when the cells get up here to this intermediate cell layer. The intermediate cell layer, they're still immature looking. They have these very large nuclei, very small cytoplasm. The NC ratio is still high. They're not supposed to do that. As they migrate upward, they're supposed to mature. They're supposed to change their cytomorphology in a way that resembles this maturity. And so the NC ratio should decrease. But the NC ratio, up about halfway up the epithelium, is still very high. These cells are not maturing properly. This epithelium is not maturing properly. Okay. Let's pop down. It's only when you get about halfway up the epithelium that you actually see some evidence of maturation. It's still not very much, but the NC ratio is beginning to drop. But that only happens after half the way up the epithelium. And so this epithelium is not maturing properly. You clearly have cells that are starting to lose proliferative control. All the cells are remaining above the basement membrane, which is a natural tissue barrier. So what you have here is an intraepithelial neoplasm. We specifically refer to this as a cervical intraepithelial neoplasm, or CIN for short. This is a form of dysplasia. It's a form of dysplasia we call moderate dysplasia, or CIN level 2 dysplasia. There's no evidence of maturation until you get about 1/2 the way up the epithelium. Yes?
What was the CIN stand for again?
Cervical intraepithelial neoplasm. because it is a neoplasm contained within the cervical epithelium. That's another way of saying dysplasia. This is a moderate form of dysplasia, and so we call this either moderate CIN or CIN level 2. All right, this is what we would describe as kind of moderate dysplasia, CIN2. Dysplasia is actually ranked with a 3-tier system, CIN1, CIN2, CIN3. This is an example of CIN2, what we call moderate dysplasia. Okay, well, there are actually worse forms of dysplasia. This is just a moderate form. Take a look at this epithelium. Here's another section through cervical epithelium. Let's analyze the cells in this epithelium. Again, we have the cervical epithelium here. There's a basement membrane running underneath here. We've got the subepithelial tissues down here, and we got the vaginal canal out here. Okay, let's take a look at this. Again, parabasal cell layer. Cells are all crowded together. High NC ratios. Okay, no big deal for the parabasal cell layer. But look what happens as the cells migrate up the epithelium. They're maintaining their immature cytomorphology. They don't mature until they get up maybe 2/3 of up the epithelium. Then, and only then, do you actually sort of see some kind of indication of maturity. The cells start to change their morphology such that the NC ratios begin to decline. Down here, the cells are very crowded together, very high NC ratios. And that persists, again, up to about 2/3 of the way up. They are still immature. Well, this is a more severe form of dysplasia. Maturity isn't occurring until 2/3 of the way up the epithelium. This is a more severe form of dysplasia. We call it CIN3, cervical intraepithelial neoplasia, stage 3, or severe dysplasia. Again, it is a neoplasm contained within the epithelium. So it's a cervical intraepithelial neoplasm. Again, another word for dysplasia. Okay. Well, this is certainly a bad form of dysplasia. But you know, dysplasia can even be worse than this. This is indeed severe, but could be even more severe. Sometimes the dysplasia is full thickness. Sometimes the cells are dysplastic throughout the entire thickness through the epithelium. There's absolutely no maturation at all in the epithelium. Okay, here's an example of a more severe form of cervical intraepithelial neoplasm dysplasia. Over here we have a section through normal epithelium, and over here we have a more severe form of dysplasia. Take a look at the normal epithelium. Again, there's the parabasal cell layer. The cells are all crowded together. High NC ratio, big deal. That's what they're supposed to be. They're all proliferating. They're all going to be immature. But immediately, as the cells migrate upward, their NC ratio declines until finally they get up to the superficial layer. They have very low NC ratios. That part of the epithelium is maturing properly. Look over here. Throughout the entire thickness of the epithelium, these cells display high NC ratios. There's almost no evidence of maturation of these cells at all. You've got full thickness dysplasia. We could call that CIN3 because it is a very severe form of dysplasia, but we have a special name for an epithelium that is dysplastic throughout its entire thickness. We call it carcinoma in situ, CIS. Carcinoma in situ. Carcinoma in situ is basically cancer just before it becomes cancer. It's the worst form of dysplasia. By definition, it's still benign. Dysplasia, by definition, is benign. But it's the most severe form of dysplastic condition you can have, and it immediately antecedes the development of cancer. Okay. What can happen here? Well, we've got full thickness dysplasia. This is carcinoma in situ for sure. Best possible thing that could happen. The woman's immune system can recognize these cells as being abnormal. And sometimes, if the woman's lucky, the immune system will attack these cells and completely destroy them, replacing the dysplastic cells with normal cells. You can actually see that's happening here. If you look underneath the basement membrane, it runs here, you'll see this. There's an accumulation of inflammatory cells there. That's a good sign. This infiltrative inflammatory cells indicates that the immune system is recognizing these cells as bad, and it's quite possible the immune system might be able to wipe them out, and this dysplastic epithelium might spontaneously resolve. That could be the best possible thing that happens to this woman. There's another possibility. This dysplastic condition can persist and maybe never degenerate into anything further. Just persist and never gives the woman another problem. There's something else, though, that can happen. Sometimes these cells can mutate further. If they mutate to the point where they turn on an enzyme that allows them to break through the basement membrane, they're going to start invading into the subepithelial tissues. And when that happens, this is no longer a dysplastic condition. This is locally invasive squamous cell carcinoma of the cervix. Let's take a look at that. All right, here is a section through cervix with cervical cancer. It's kind of a lower power. The cervical os is over here. That's the cervical os. And over here you can see some normal cervical epithelium. Okay, there's some normal cervical epithelium right there. Okay? You can kind of see that this epithelium is maturing properly. The parabasal cell layer, you can see, is kind of hyperchromatic. It stains very darkly. That's because the cells are kind of packed together. They're very immature. But you can see as the cells migrate upward, they kind of spread out. Their NC ratios decline, and they become very pale staining. That tells you that this part of the epithelium is maturing properly. Everything's looking good over here. Take a look over here to the left. Look at this part of the epithelium. You've got this dark staining pattern throughout. That's because the cells are all crowded together, and the NC ratio is very high. Clearly, this part of the epithelium is not maturing properly. Now, if this were the only problem with the cervix, you'd say, oh, that's dysplasia. That's probably carcinoma in situ. Unfortunately, that's not the only problem here. We've got a basement membrane that's running underneath here, okay, like this. And you'll notice over here, you've got cells that have penetrated the basement membrane. They've locally invaded the basement membrane. They've breached a natural tissue barrier. And not only have they punched through, but look, they're making little satellite lesions in the subepithelial tissues. This isn't a dysplastic cervix anymore. This is squamous cell carcinoma of the cervix. And this is a whole different thing. This isn't benign anymore. This is cancer. Any questions on this? Okay. Let's take a look at what cervical cancer would look like macroscopically. Okay, so we've looked at a normal cervix. Here's the normal cervix. Again, smooth, shiny, glistening. Okay, cervical os. Everything looks good here. This is what a normal cervix looks like. Here's what squamous cell carcinoma of the cervix looks like. You can see the cervix here. This would be the ectocervix. And the cervical os should be here, but you don't see it. There should be an opening right here. You can see the opening's been obliterated by these 3 nodules here. Those are the nodules of squamous cell carcinoma. This is a rather advanced case of squamous cell carcinoma of the cervix. Any questions here? Okay. All right, the next thing we want to do is investigate a little further the difference between benign and malignant neoplasms. We've already defined some of the major characteristics of benign and malignant neoplasms. By definition, benign neoplasms only grow locally. They have no ability to invade. They have no ability to metastasize. In contrast, malignant neoplasms, which are also called cancers, have the ability not only to grow locally, but they can breach natural tissue barriers, i.e. they can locally invade, and the cells of that malignant neoplasm can detach from the primary mass, get into the bloodstream, lymphatics, and disseminate all over the place. That's called metastatic dissemination. That is a feature that defines malignancy. So we have two features that define malignancy: local invasion and metastatic dissemination. Any neoplasm locally invades and or metastatically metastasizes, or metastatically spreads, is by definition a malignant neoplasm. Okay, we're going to explore those characteristic features a little further, but why don't we take a break just a little early, and then we'll get into it and we won't be interrupted.